In this video lecture, let me discuss about the boiler troubles. The water which is fed into the boiler is called boiler feed water, and there are certain requirements for this boiler feed water, and if that requirement is not satisfied, it will lead to certain problems. If the boiler water contains hardness causing ions, it will cause scale and sludge. If it contains suspended impurities, it will lead to priming and foaming. If it contains dissolved gases like oxygen, carbon dioxide, it will cause boiler corrosion. If it contains alkalinity causing ions, it will lead to caustic embrittlement. We'll discuss these problems one by one. Scale and sludge. Consider a boiler containing the boiler water. The water not only contains H plus and OH minus ions, it also contains dissolved salts, that is other cations and anions. When the boiler is continuously heated, these salts will reach a saturation point, and after the saturation point, they are thrown out as precipitate. Sometimes the precipitate can be either hard or soft. The hard precipitate is called as scale and the soft precipitate is called as sludge. The scale causing salts include calcium sulfate, magnesium hydroxide, and the sludge causing salts include calcium chloride, magnesium sulfate, etc. The scale causing salts move near the wall of the boiler and they adhere well to the boiler wall. The sludge is suspended and they will settle at the bottom of the boiler if the boiler is undisturbed. Disadvantages. Both scale and sludge reduce the efficiency of the boiler and they are poor conductor of heat. Because of this, there is wastage of fuel and sometimes scale will lead to boiler explosion. How we can prevent? Instead of using hard water, we can use soft water. Scale can be removed by using dilute acids, scrapers. Sludge can be removed by blowdown operation. Priming and foaming. When the boiler water is continuously heated, due to the presence of impurities, there is formation of bubbles, which is nothing but a process called foaming. Apart from the formation of bubbles, steam is produced, and sometimes the steam produced will carry the water droplet, which is called as wet steam. The process of production of wet steam is called priming, and the whole process of producing the bubbles, steam carrying the water droplet is called carryover. Priming is due to high steam velocity, high water level, and poor boiler design. We can prevent the priming by controlling the steam velocity, maintaining low water level, good boiler design, and using treated water. Foaming can be prevented by using coagulants and by using anti-foaming agents. Boiler corrosion due to dissolved oxygen. Oxygen reacts with the metal ion in presence of water and form ferrous hydroxide. Dissolved carbon dioxide. Carbon dioxide reacts with water to form carbonic acid. Dissolved salts. Consider magnesium chloride. It reacts with water to form magnesium hydroxide and HCl. This acid will react with the metal and form iron chloride, which in turn react with water to form ferrous hydroxide. We can remove the dissolved oxygen by adding certain chemicals. When we add hydrogen, hydrogen reacts with oxygen and form nitrogen and water molecule. Removal of carbon dioxide by using ammonium hydroxide. Ammonium hydroxide with carbon dioxide form ammonium carbonate and water. Here oxygen and carbon dioxide is converted into some compound. Removal of acids by adding some base. HCl with sodium hydroxide gives sodium chloride and water. Apart from this chemical method, we can also use mechanical method by using mechanical deaerator. It consists of a tower with the perforated plates inside, and it is connected to a vacuum pump, and outer it has a jacket which is heated to a high temperature, and the condition here is high temperature and low pressure. When we pass the water when it reaches the perforated plates, since high temperature is maintained, water is converted into vapor where all the gases are removed since it is connected to the vacuum pump, and they condense at the bottom of the tower, which is called as the deaerated water. Caustic embrittlement. In high pressure boilers, in order to remove the scales, we make use of chemical sodium carbonate. Sodium carbonate reacts with water and forms sodium hydroxide. This sodium hydroxide flows into the minute air cracks, and through capillary action they dissolve the surrounding metal. Iron with sodium hydroxide forms sodium ferroate and hydrogen. And we can prevent the caustic embrittlement by using sodium phosphate instead of sodium carbonate in high pressure boilers, and by adding tannin and lignin, which will block the minute air cracks. Thank you for watching this video lecture.